Look ahead. Focus. Right there. Sharp. Clear. Detailed. All of it? No. Just here. One spot. Tiny. A pit. A hole. Dead center. Your best vision. From a hole? There is a hole in your sight. It sits at the very center. It is called the fovea. Fovea means pit in Latin. It is smaller than a pinhead, yet it is your sharpest spot. Everything else is a blur, you just never notice. Start here. Point your eyes at a single letter on this screen. That letter is sharp. Now, without moving your eyes, try to read the words beside it. You cannot. They smear into a soft gray blur. Only the letter you aimed at stays clear. That clear patch is astonishingly small. It is about 1 degree wide, roughly the width of your thumbnail held at arm's length. Step your attention just a little to the side and detail collapses. Everything outside that patch is rough, low detail, and half-guessed. Yet your world does not look blurry. It looks sharp from edge to edge. That feeling is the puzzle, and the answer sits inside a pit. Deep in the back of your eye is a thin sheet called the retina. It is the layer that catches light. Think of it as the screen where your image forms. Near its center is a small dimple. That dimple is the fovea. It is only about 1.5 millimeters across. Its sharpest core is smaller still, barely 1/3 of a millimeter wide, a speck you could hide under a grain of rice. And into that speck your whole detailed world is squeezed. To understand how the pit sharpens your sight, look at how the retina is built. The retina is not a simple screen. The cells that catch light sit at the very back. In front of them lie layers of nerve cells and wiring. Everywhere else, light has to pass through that tangle first. It is like looking through a thin, living mesh. Some light scatters on the way, some detail softens. But at the fovea, that mesh is swept aside. The upper layers are pushed outward, sloping away from the center. That sideways shift is what forms the pit. So light lands on the receptors almost cleanly. Fewer cells in the way means a crisper image. The pit is not a gap in your sight. It is a cleared path for light. Now look at what fills that clearing. Your retina holds 2 kinds of light catchers. Rods handle dim light and see no color. Cones handle bright light and carry fine detail and color. Across most of the retina, rods vastly outnumber cones. But the foveal center flips that completely. There, cones are packed shoulder to shoulder, and rods are almost entirely absent. The cones there are also thinner and more tightly crammed than anywhere else. Tighter packing means finer sampling. Finer sampling means sharper sight. This single spot holds the densest detail sensors in your eye. Those cones also come in 3 kinds, tuned to different colors. So your richest color lives in the very same speck. In 1935, a scientist named Gunnar Osterberg did something painstaking. He counted the light catchers across the human retina, region by region. His maps showed cone density rising to a steep peak at the fovea. At that peak, cones crowd in at over 100,000 per square millimeter, move outward, and their number drops away fast. It was the first clear picture of how lopsided your retina really is. Your sharpness is not spread out, it is concentrated. There is one more trick hidden in the pit. Your retina is fed by blood vessels that branch across its surface. Those vessels sit in front of the light catchers. Anywhere they run, they cast faint shadows. But across the very center of the fovea, they part. No large vessels cross your sharpest spot. That tiny patch is fed from behind instead. So nothing is stretched across the window where you see best. The clearing is kept clear on every side. Then comes the wiring. Elsewhere in the retina, many receptors pool into a single line to the brain. Dozens of rods can share one cable. That pooling boosts sensitivity in the dark, but it blurs detail. At the fovea, the rule changes. Each central cone gets close to its own private line. One receptor, one channel, one thread of detail. Nothing is averaged away. That is why the finest print, the smallest star, the thinnest hair falls only on this spot. For most of history, no one could see any of this in a living eye. Then, in 1851, Hermann von Helmholtz built a small instrument. He called it the ophthalmoscope. It shines light into the eye and lets you look straight back at the retina. For the first time, the living fovea could be seen, a faint dip glinting at the center of the sight. Helmholtz helped turn vision from guesswork into measured optics. Today, the pit can be mapped in cross-section. A modern scan called optical coherence tomography slices light through the retina. It reveals the fovea in profile, a clean valley, layers swept aside, dipping to a narrow floor. The pit you carry is now something a machine can draw. So here is the strange truth. Your sharp, detailed vision comes from a spot the size of a pinhead. Everything else is blur. Which raises an obvious problem. How do you ever see a whole face, a whole page, a whole room in detail? You do not. Not all at once. Instead, your eyes move. They do not glide smoothly across a scene. They jump. Quick, darting flicks, several times every second. Each jump lands the fovea on a new target. Between the jumps, the eye holds briefly and takes a sample. Then it flicks again. These jumps have a name. In the 1870s, Louis-Émile Jouval studied the eyes of people reading. He watched them hop, not slide, along each line. He called those hops saccades. Your eyes make them constantly, mostly without your knowing. Right now, reading this, your gaze is leaping word to word. Each leap drops the pit onto the next few letters. And even when you try to hold perfectly still, your eyes never do. They tremble in tiny, constant movements you cannot feel. This matters more than it sounds. If an image were frozen in place on your receptors, it would slowly fade from view. The cells stop responding to a signal that never changes. So the small tremor keeps the world refreshed on the pit. Your stillest stare is quietly, endlessly in motion. Your brain takes all these rapid samples and does the rest. It stitches the sharp scraps together. It fills the blurry edges from memory and expectation. It smooths over every jump so you never feel the motion. The seamless, sharp world you seem to see is largely built, not received. You are shown a pinhole and handed a panorama. You can catch the trick in the act. Hold your gaze fixed on one word. Notice how quickly the sentence around it falls apart. Look at a friend's face and fix on one eye. You cannot hold both eyes and the mouth in sharp focus at once. Your fovea has to jump between them. It always did. You simply never felt it. Watch a crowd, and only one face is ever truly sharp. The rest is a soft, guessed backdrop your brain paints in. Try one more test at the edge of your sight. Hold a colored object far out to the side and look straight ahead. You can sense that something is there, but the color barely reads. The far edges of your retina are nearly colorblind. Almost all your color, like almost all your detail, lives in the pit. Think about that the next time you read. Every clear line reaches you through a hole smaller than a pinhead. Every sharp face is assembled from tiny, darting glimpses. The richness feels effortless. The machinery is anything but. A pit, a crowd of cones, a private line each, and eyes that never stop moving. So look ahead again. The scene feels whole, sharp, and still. It is none of those things. It is a hole in the middle of your sight, doing quiet, relentless work. And now you will never see that center the same way again.